Hey, how's it going, guys? Today we'll be looking at histone modification in order to turn transcription on. And so you have these things called histones, and there's 8 of them, and what happens is DNA is tightly wound around it. The tight packing of the DNA allows it to be contained within the nucleus, and so what needs to happen is the histones need to be opened up so that the cell's machinery can access the DNA to transcribe it. So what you need is this thing called histone methyltransferase. This is part of a complex called trithorax, and so this is labeled as TRX. The trithorax complex methylates, and so methylation can take one of 2 forms. One can methylate a permissive mark or a repressive mark. In this case, the histone methyltransferase methylates the H3K4, which is a permissive mark. And so permissive means that it allows the process to continue through it. It permits transcription to occur. And so this methylated H3K4 is read by a methyl reader. This methyl reader is called a chromodomain. And so the chromodomain reads this H3K4 methylated permissive mark, and what it does is it needs to remove the repressive mark, so the thing that's stopping the process from occurring. And so H3K9 is erased, and H3K9 is actually a repressive mark, and so the repressive mark has to be erased in order for the permissive mark to work. And so what happens is, the thing that erases the H3K9 is a thing called histone demethylase, and so this demethylates the H3K9, therefore inactivating it. Once this has all occurred, a molecule called histone acetyltransferase is recruited by the chromodomain. The histone acetyltransferase, its role is to acetylate the histones. Acetylating the histones, what it does is it opens up the histones. Opening up the histones means that the cell's machinery can access the DNA. And so what it does is it undergoes chromatin remodeling. So the acetylation leads to chromatin remodeling, and so these acetylated things are read by a bromodomain which does it. So the bromodomain reads these acetyl tags on the histones, and it does the chromatin remodeling so that the DNA is unbound from the histones. And so what that allows is for the tartar box to be exposed. If you remember what a tartar box is, it's right at the beginning of the DNA strand, and that allows RNA polymerase to bind onto the DNA. And so that's exactly what it does. Once the tartar box is exposed, RNA polymerase can bind to the DNA template strand and produce an mRNA strand. And in which case, what the RNA polymerase, in doing so, what that means is that transcription has successfully been turned on. So transcription being turned on is good. It means that the cell can get whatever new create new cells as needed. And so in summary, what's going on is this: the trithorax, which has the histone methyltransferase in it, it methylates H3K4, which is a permissive mark. This methylated H3K4 is read by a methyl reader called chromodomain. The chromodomain, upon reading it, erases the H3K9 repressive mark using histone demethylase. Then histone acetyltransferase acetylates the histone so that the chromatin becomes remodeled, exposing the tartar box, and so RNA polymerase can bind to it and then therefore turn transcription on. I hope that's been helpful. Bye.